Hello, 8th grade, and welcome to your Unit 1 review for your test. So we are going to go through each of these questions with the answers so that you can be the best prepared that you can be for your test tomorrow. All right, so question 1 says you have been hired by a company to write a report on internet companies' Wi-Fi ranges. They have requested that all values be reported in feet using scientific notation. Stevens Internet Company boasts that its wireless access points have the greatest range. The company claims that you can access its signal up to 2,640 feet from its device. A competing company, Winifred's Wi-Fi, has devices that extend up to 2.5 miles. Question A says rewrite the range of each company's wireless access devices in feet using scientific notation and state which company actually has the greater range. So first we have Steven. His is 2,640. If I change that to scientific notation, I'm going to have 2.64 times 10, and that decimal point is moving 1, 2, 3 spaces, 10 to the third. Now we need to figure out Winifred. So information that we need to know is that there's 5,280 feet equals 1 mile. So I need to multiply 5,280 times this 2.5 to figure out how many feet. So I'm going to do 5,280 times 2.5. 5 times 0 is 0. 5 times 8 is 40. 5 times 2 is 10, plus 4, 14. 5 times 5 is 25, plus 1 is 26. I'm going to add my 0 as the multiplication rule. 2 times 0 is 0. 2 times 8 is 16. 2 times 2 is 4, plus 1 is 5. 2 times 5 is 10, plus 1 is 11. So I'm going to add that together, 0, 0, 10, 6, 11, 12, 2, 3, 4, 1. Hold on, I did something wrong. Oh, sorry, that's supposed to be a 10. And that is a 3. Rules of multiplication, I have 1 decimal. So my decimal goes there. So Winifred's then is 13,200 feet, which translates to 1.32 times 10. And I'm moving the decimal 1, 2, 3, 4 spaces. So now if I'm comparing these, I can use the exponents. 4 is larger than 3. So Winifred has the larger distance, has the larger range. Okay. You can determine how many times greater the range of one internet company is than the other by writing their ranges as a ratio. Write and find the value of the ratio that compares the range of Winifred's, so I need Winifred's, wireless access device to the range of Stevens. Wireless access device. Write a sentence describing how many times greater Winifred's Wi-Fi range is than Stevens' Wi-Fi. So Winifred's we have up here as 1.32 times 10 to the 4th. And we're writing this as a ratio to 2.64 times 10 to the 3rd. So now we're trying to figure out how many times greater it is. So we have to divide these. So I'm going to do 1.32 times 10 to the 4th divided by 2.64 times 10 to the 3rd. So if you notice, this is half of that. So I'm going to have 1/2 times 10. Here we have 4 and 3. If I subtract those using our laws of exponents, that becomes 10 to the 1st. So this then becomes, I can change that to a decimal as 0.5 times 10 to the 1st. our rules of scientific notation, this cannot work. So if I multiply this, it becomes 50. So Winifred's is 50 times greater. Oh, sorry. Doing my math wrong. 5 times greater. Moving too many decimals. All right. UW-Madison uses Wi-Fi over long distances to create long-distance point-to-point links. UW-Madison claims that the connections can be made up to 10 miles away from its device. Write and find the value of the ratio that compares the range of Stevens wireless access devices to the range of UW-Madison's devices. Write your answer in a complete sentence. So we have Stephen, which we have that information from above. He is 2.64 times 10 to the third. And now we have to figure out UW-Madison. So that is 10 miles, so we can do 5,280 times 10, which is going to give us 5,200. Or we can write that as 5.28 times 10, and I'm moving this 1, 2, 3, 4 units. So write and find the value of the ratio that compares, so we're doing Stephen to UW-Madison. So Stephen then is 2.64 times 10 to the third to 5.28 times 10 to the fourth. And then again, we are comparing. Oh, yep. Write and find the value of the ratio that compares the range. And then just explain that somehow in a sentence. Stephen's range is less, and we can even calculate that out too again. So 2.64 times 10 to the third divided by 5.28 times 10 to the fourth. This looks double. Let's check that out. 2.64 divided by 5.28 is in fact 1/2. So that is 1/2 again, times 10 to the negative 1. Our laws of exponents flip that. So we're going to have 2 times 10 to the first, or 20. Madison's is 20 times greater. UW-Madison. Range is 20 times greater. All right, let's move on to the second page. There is still a controversy about whether or not Pluto should be considered a planet. Although planets are mainly defined by their orbital path, the issue of size is something to consider. The table below lists the planets, including Pluto, and their approximate diameters in meters. So here we have all of the planets. Here we have their size. Name the planets, including Pluto, in order from smallest to largest. So we're going to list 2, 3, 4, 5, 6, 7, 8, 9. So we can start by looking at the exponents. So I have a 6, a 6, and a 6. Those are my smallest. So now I'm going to look at the values. So 2.3 is the smallest, so Pluto. And then I can look at the next ones. So we're going to cross that off because we're done with that. Mercury is next. And then last is Mars. Okay, let's look at the 7s now. I have 1, 2, 3, 4 7s. So here Venus has 1.21. Earth is next at 1.28. Neptune would be next at 4.96. And Uranus is 7th Then I've got 2 planets left. So 1.27 is Saturn times 10 to the 8th. And Jupiter is last. So that's all you have to do for that question. For B, comparing only diameters, about how many times larger is Jupiter than Pluto? So we're going to do Jupiter. We're going to divide that by Pluto. So Jupiter was then 1.43 times 10 to the 8th. And we're dividing Pluto 2.3 times 10 to the 6th. These numbers are a little messy, so we'll grab the calculator over here. So I'm going to do 1.43 divided by 2.3, which gives me 0.62 times 10. If I'm using these laws of exponents, I'm subtracting, so that's going to be 2. However, I now need to move this because I can't have my scientific notation be less than 1. So this becomes 6.2 times 10 to the 1st because I'm taking away a point from here and adding it there. Comparing only diameters, how many times larger is Jupiter than Mercury? So again, we're going to do Jupiter divided by Mercury. Jupiter we have is 1.43 times 10 to the 8th. We already know that from above. Come up here to find Mercury. Mercury is 4.88 times 10 to the 8th. We'll grab our calculators again. 1.43 divided by 4.88 gives us 0.293 times 10. 8 minus 8 is 0, so that's 0. Anything to the 0 power is 1, so it's roughly 0.293 times larger. Oh, you know what? That's supposed to be a 6. I messed up. So this is actually a 2. And we're going to do the same thing we did. Sorry. It's hard to hold the phone and erase at the same time. All right, so this gets moved over 2.93 times 10 to the 1st. Okay. Comparing only diameters, about how many times larger is Jupiter than Earth? So we have Jupiter again at 1.43 times 10 to the 8th, and Earth up here at 1.28 times 10 to the 7th. So we're going to divide those values. Let's grab the calculator one more time. 1.43 divided by 1.28 is 1.117 times 10. Our rules of exponents, we subtract, so 8 minus 7 is 1. 1.117 times 10 to the 1st. All right. Mr. Andrew here wondered how big a planet would be if its diameter was the square of Pluto's diameter. If the diameter of Pluto in terms of meters were squared, what would the diameter of the new planet be? Write your answer in scientific notation. So we're coming over here. We're finding Pluto, 2.3 times 10 to the 6th. 2.3 times 10 to the 6th, and I'm multiplying that 2.3 times 10 to the 6th. So when I'm multiplying exponents, I add them. So I'm going to end up with times 10 to the 12th. When I'm multiplying these, 3 times 3 is 9, 6. So this ends up being 6, 9, 15, 759. Nope, 7.59 times 10 to the 12th, because I have to add those decimal points back in that I added. So 7.59 times 10 to the 12th times larger. Or wait, sorry, not times larger. Would be the diameter of the planet. All right, and these are the ones that everybody was getting stuck on, so let's work them through together. Your friend Jeremy bought a fish tank that has a volume of 175 biscuits. Your friend Jeremy bought a fish tank that has a volume of 175 liters. The brochure for Jeremy's tank lists a fun fact that it would take 7.43 times 10 to the 18 of these same tanks to fill all the oceans in the world. Jeremy thinks that both of you can quickly calculate the volume of all the oceans in the world using the fun fact and the size. So given that 1 liter equals 1.0 times 10 to the negative 12th cubic kilometers, rewrite the size of the tank in cubic kilometers using scientific notation. So we have 1 to 1.0 times 10 to the negative 12th. We currently have 175, so we're trying to figure out what that would equal. If you notice, this is 1 to 1 almost. It is a 1 to 1 ratio. I can just multiply that. So this ends up being 175 times 10 to the negative 12th, but I have these two extra values here, so I need to move this 1, 2. So since I'm moving to the left, this ends up being 1.75 times 10 to the negative 10. So that is our answer for that one. One second, friends. Not prepared like I should be. Right. All right. B then says, determine the volume of all the oceans in the world in cubic kilometers using the fun fact. So we have this one tank, and 7.43 times 10 to the 18th of these are going to determine how, sorry guys, is what we need to do. So what we're doing is we are taking that value and we are multiplying it together. Make sure I'm giving you guys the right values. Okay, sorry. All right, so again, let's work through this. So we have 7.43 times 10 to the 18th of these 175 liter tanks. So we're trying to figure out how much that would be. So we're multiplying 1.75 times 10 to the negative 10 times 7.43 times 10 to the 18th. So I can multiply these together. We'll grab our calculator right quick. Don't worry, I won't give you numbers like this on your test. So this becomes 13.0025 times 10. Now we need to work with this. When we're multiplying our exponents, we add them. So I have a negative 10 plus 18 gives me an 8. However, I need to move this decimal one more time because I can only have my numbers, I can't have a number larger than 10. So this becomes 1.30025 times 10 to the 9th. So that is cubic kilometers. All right, you like Jeremy's fish so much that you bought a fish tank of your own that holds an additional 75 liters. So we have Jeremy's fish tank plus yours. Jeremy's was 175 plus 75 equals 250 liters. Jeremy asked you to figure out a different fun fact for your fish tank. Jeremy wants to know how many tanks of this new size would be needed to, and that should say fill, the Atlantic Ocean. The Atlantic Ocean has a volume of 323,600,000 cubic kilometers. So we need to rewrite this in terms of our cubic kilometers again. So we're going to use the same information as up here. So we had our 1 to 1 times 1 to negative 12th ratio. We have 250 liters, which is going to make this 250 times 10 to the negative 12. Or because we have a number larger than 10, we need to switch that. So this is going to become 2.5 times 10. And since I moved 2 to the left, this becomes to the negative 10. Now I need to rewrite this as a scientific notation. So this is going to become 3.236 times 10. And let's see how many times I'm moving this. 1, 2, 3, 4, 5, 6, 7, 8 to the 8th power. So I need to again divide, in this case, to see how many tanks would fill this. So I'm going to do 3.236 times 10 to the 8th divided by 2.5 times 10 to the negative 10. We can come over here and grab our calculators. 3.236 divided by 2.25 is 1.294 times 10. Our rules of exponents say that we're going to subtract these. So I have 8 minus 10, which is the same as adding 8 plus 10 times 10 to the 18th power, which is similar to our original answer for the volumes. All right, that is the review. Please let me know if you have any questions, and good luck tomorrow.